Welcome back to Advent of Code 2015. Jumping right into day 18, like a GIF for your yard. After the Million Lights incident, the fire code has gotten stricter. Now at most 10,000 lights are allowed. This was day 6. Probably a fire hazard. You arrange them in a 100 by 100 grid. Never want to let you down, Santa again mails you instructions on the ideal lighting configuration. So with a few lights, he says you'll have to resort to animation. With so few lights, he says you'll have to resort to animation. Start by setting your lights to the included initial configuration. Your puzzle input A hashtag means on and dot means off. Then animate your grid in steps where each step decides the next configuration based on the current one. Each light's next state, either on or off, depends on its current state and the current states of the 8 lights adjacent to it, including diagonals. Lights on the edge of the grid might have fewer than 8 neighbors. The missing ones always count as off. For example, in a simplified 6 times 6 grid, the light marked as A has the neighbors 1 to 8 here, and then B has 1 through 5. The state a light should have next is based on its current state, on or off, plus the number of neighbors. A light switch which is on stays on when 2 or 3 neighbors are on and turns off otherwise. A light switch which is off turns on if exactly 3 neighbors are on, stays off otherwise. All of the lights update simultaneously. They all consider the same current state before moving to the next. Here's a few steps. Example. So this one has no neighbors, so it turns off. And this one has 2 neighbors, so it stays on. Okay. Let's check the input. Okay, grid input. And how many lights are on after 100 steps? Let's just start with this example. Part probably put some buffering around it. Dotted line. Repeat raw dot size plus 2 times a dot. Do this. And then I just join. Join to string. Then I want to add dotted line, list while dotted line. And then we add dotted line plus raw, postfix. Actually, no, we already have a list of strings. We just have to prepend it. See what we have now, just to check. We're starting with some dots and we end with some dots, and we want to now put a dot on each side here as well. So that is raw, maybe this can be processed. Raw.map each line, which each line being dot plus it plus dot. Or this. And then we map here this. Then we have this grid with extra dots. Now it's super easy, so we can always look at all the neighbors. 1, 2, 3, 4, 5, 6, 7, 8. Count them. Buffer dot for we can just go reach x, reach y, we have buffer and x and y. If this is a hashtag, then we want to check the neighbors around it, which is neighbors nays is so also here we can go pair. Oh, actually I like using my own class, just x, y. I can do p of x and y. Don't 0, 0. Otherwise, this should be a nays. So for each neighbor, we can take buffered add a neighbor Oh no, we need p of x and y. Check x of is x plus nay dot x. Check y is y plus nay dot y. And then we have to go into buffered at check y if that is a hashtag. Then we want to basically count, right? So we count how many are hashtags. Hashtags. Okay, lights on neighbors. If lights on nays. Okay, depends now if. Oh no, we know that we are on. Okay, a light which is on, that's our case. And we stay on when 2 or 3 neighbors are on. 2, 3. Then we stay on. Otherwise we go off. So if we're not in 2, 3, dot. And we have a problem. No, I think we have to kind of create a new buffered. Next buffered equals buffered. Not sure if buffered is the right word. Anyway, we need a next one, which is basically buffer dot to mutable mutable, something like that, and then we can do new buffered next. It's changed. So we always check the current one and we update all the next ones. And then in the next round we check the next as the current one and update another next one. Okay, so if we are not, else we are now we're kind of like when this, then else so something like that. Yeah, I guess you could do like this. Else we go and say we are, actually we just need buffered to be dot. If it's dot we have off. If exactly 3 neighbors are on, we turn on. So we do the same thing. So we can do it outside, I guess. On only this. have to say. If light on nades equals 3, next x, y equals hashtag. And we do this, all of this, 4 times. Let's do it once actually. Print line, no, next for each print line. Maybe we should buffer with something else. And then we have to do this here. Okay, so now I have nice padding outside, and the box in the middle has only the dots, so we only check the ones. And then our second one looks like this, so like a V here, and then structure here, and that looks correct. Now I want to repeat it 4 times, and I don't know if it'll work. Something with, okay. Well, all we need to do is date buffered. And then next buffered gets reset. Let's see. Okay, that's perfect. Try the big one. And we actually need to do something else. We need to buffer each line, for each symbol or whatever. If s we count the lights or something. After 100 steps, how many lights are on? Okay, let's do it. $814, and that's correct. You flip the instructions over. Santa goes on to point out that this is all just an implementation of Conway's Game of Life. At least it was, until you notice that something's wrong with the grid of lights you bought. 4 lights, 1 in each corner, are stuck on and can't be turned off. The example above will actually run like this. So we have lights in the corner that stay on. Okay. Let's do this. And then we need to have at the end 17. So we just have to hard code the corners. maybe I can do like a fix function, which is dot fix returns a list string. Okay. And it has this, and then I just say mute at 1, and 1 is 1, and this dot last index -1. So I just map it.join to string again. Then we're returning list of string. Okay, so we're fixing it, and then after here we also fix. Maybe it's 19, interestingly, and not 17. Oh, somehow the example has 5 steps. Now we have 18. Still not 17. Let's check the very first one. Go from here to top row on. Okay, that's not correct. Do we have this one correct? Yeah, we have this correct. We fixed the no, we fixed the wrong one. We have to fix this one. And we get 17. Let's jump to this big one. Did we do 100 steps? No. Nine, 2, 4, and that's it. Let's have a look. So basically, yeah, we just need to, at the beginning, when I make my initial field, apply the fix function, which just turns all the corner lights on. Then I go through the process of turning lights on and off and so on. Based on the current state, I make the next state, next buffered, and then before I update the current state to be the last one, to be the next one, I turn the corner lights on again, and that's it. Thanks everyone. See you next time.